Science Beetle.
Hey, welcome back, students. In this video, I want to go ahead and talk to you about intensive properties. And so in the previous video, if you saw that one, you would have noticed that I kind of went over extensive properties. And like in that video, I want to go ahead and point some stuff out. Remember here that when we're talking about properties, what we are referring to are these characteristics. Okay, so these are going to be characteristics of matter. Okay, and this term intensive is essentially referring to a condition in which it's the measurement of this particular property is not really going to depend on the matter. It's really intensive. It does, in other words, it's not affected by the quantity. And so that's what this really means here. So it's going to say here, not affected by the amount. And I'm just going to use the word quantity of matter. Okay. Now, since it's not affected by the quantity of matter present, then that means that when you look at the measurements here of some of these properties, these are going to be things that are really going to be independent of the amount present overall, in the sense that mass is not going to impact it, the volume is not going to impact it, because the end result of that measurement is not going to change no matter how much you either increase or decrease the amount of matter that you have. There's a couple of these properties that you should know. One of the most common one here, and I'm going to go ahead and put this in red over here on the top right corner, is that these intensive properties, one of the ones that you should know at the very beginning is going to be this one. That's going to be the density. Okay. Now remember that density is a derived unit of measure in the metric or in the international system of measure. And so density, remember, is equal to here the mass over the volume. And so a common question that we usually get is, well, wait a second, but I thought mass was one of those things that is extensive. So the amount matters. Well, yeah, for mass it does. And also you said that volume was one of those properties that also depends on how much you have. So it would also be extensive. And yes, it would. And if you think about that for a second, what's happening here is that you have a extensive property over an extensive property. And so think of this kind of like in math, it's going to cancel out. So at the very end, what you've got here is essentially going to be some value here of 1, right? This generic 1. So essentially any kind of dependence on amount is going to be eliminated, excluded from that discussion. And so as a result here, what we've got to consider here with respect to density is that the matter here, the amount that you have, is going to be irrelevant in the overall measurement. Okay, and so how do we figure that out? Well, it's kind of like this. And so let me just run through a very quick example with you. Okay, I'm going to do a mathematical thing here. So let me make some of this stuff a little bit smaller. Move this over this way. Do it like that to just give me some space. And so we'll do the following. Okay, so let's go ahead and break this up here. And so what we'll do is the following here. We're going to take a mass. And let's say that we start off with this mass here. Let me use, let's see if I can change the color here. Let's use this color now. Okay, and so let's say that we take a mass here. And let's say that we're going to take a very generic sample here of matter. Let's say that the matter here is this purple, okay, this oval structure. And let's say that we weigh this, and the mass here is going to be 10 grams. Okay, and let's say that I'm going to place this in a container. So here we got 10 grams. And let's say that the volume that I'm going to place it inside, okay, let's say that I go ahead and place this in the water. This is one of the most common ways that we get this. We take some cylinder and we put it in there, and the cylinder is graduated here. And let's say that we fill it up with a little bit of water to begin with. And then we add this sample to it. Okay, so we get this in and we put it in here. And when you put it in there, what happens to the water? Well, the water is going to rise. And so let's take a look at the original value here. Let's say here this was 1, 2, 3. Let's say 3 milliliters there. And when it rises, the water then goes up to a little bit higher volume. And so let's say that the water raises up to the second level here. Generically, I know I'm making this up, but let's pretend that it goes there. And so the reading here is now at this reading here, and that would be 5 milliliters. So this number here, the 3, essentially is the initial. And the 5 milliliters here is the final. Okay, so if you want to figure out what's the overall volume that this particular purple oval structure occupies, what you're going to do is you're going to take the final minus the initial. Okay, so I set it up like that already here. So let's just put this here minus the 3. So that will give you a total change of 2 milliliters. This here is the change in volume. Okay, and so this volume here that we're looking at is going to be this change here. So this amount here in the 2 milliliters is what we're going to put here in that area. And so that number there should be, and I'm going to leave that in green, and so that here should be 2 milliliters. So when we actually put this together in the equation, what we've got here is 10 grams divided by 2 milliliters. And if you do the math there, that's going to be 5 grams per milliliter. Okay. Now, this is the way you get the density. But what if we are able to change the amounts here? What if we do this changes again and we repeat this experiment? So let's go ahead and repeat it. What I'm going to do is I'm going to capture this one here and just move it over. And what I'm going to do is just erase some of the items that I had before. So let's just erase some of this stuff here. And let's go ahead and erase this just to show the original container, right? And so I'm going to erase these items as well here, only because those are not the markings anymore, but I will put the markings back. And so there's a marking, there's a marking, there's a marking. And so that way we have consistency. It's the same container overall. All I did was a copy of it. And so let's go ahead and make a copy of the ball here. So here's one. Actually, let's put them over here on the side for now. And let's make another copy of it just to have them ready. So if we go ahead and go in there now and fill up the water like we did before. So let's fill it up like we did here at the very beginning. We filled it up here to this amount here. And then we're just going to go ahead and add the 1 inside. And when we add the 1 inside, obviously the water goes up. And so initially we had said if we add 1, the water goes from that, what we had said 3 initially, right? So let's kind of be consistent there. So we said the water was initially at 3. We add the second, that oval structure there, and it'll go up to the 5. And so it goes up to this level here. Here's the 5, right? And so the initial value here was at 3. And so what we're going to see is that the water went up to 5 when we added the first one. Let's see if we kind of add the other one here. We add the other dot, and let me bring this to the front. And so bring to the front, and so let's do that now. And so then we can bring this in, and we can put it there. And so what's going to happen now? So well, what's going to happen here is, let's say that when we put that second one in, actually it comes up, goes in here, and it comes up to this level there. Okay. Now if we do that measurement there, we look at that, that'll be 1, 2, 3, 4, 5, 6. And it actually is up here at the 7 mark. So 7 milliliters there. If we do the difference again, the top number is the final. The initial is at the bottom, so I'm just going to label those F and I respectively. So 7 minus the 3 gives you a total difference here of 4 milliliters in terms of volume change. Okay, and so this is going to be the volume change. So when we do the math here at the different masses now, so here we'll take the total mass now, since we had 2 of these rocks, so that means we've got a total mass of 20 grams divided by the mass or the volume change, which is 4 milliliters. And if we do the math there, 20 divided by 4 is going to give you 5 grams per milliliter. So notice the main difference here. So this essentially is equal to 1 rock, and the one at the bottom, which I'm going to circle in green, this is actually equal to 2 rocks. Notice that the value for density did not change, even though the mass increased and the volume difference increased. But intensive properties then are essentially going to be these properties that do not depend on the amount of matter that is present. Now there are a couple of other properties that you should know about in this room. I just talked about density here, but remember there's also properties kind of like melting point. Okay, and another property here would be the boiling point. And the idea is it doesn't matter how much property or how much matter you have. When you have a sample of aluminum, for example, it's going to melt at a certain temperature, and it doesn't matter if you have a small amount, 10 grams or 100 grams, it will always melt at that temperature. Just like water will always boil at the temperature that we know water to boil at. Okay, and so that would be 212 degrees Fahrenheit, 100 degrees Celsius. And so it does not matter if you have 1 cup, 1 gallon, 1 little teaspoon, water will always boil at that temperature. But with regards to intensive properties, the amount of matter that you have is not going to affect the overall measurement that you're looking for in that particular property. So if you haven't already done so, go ahead and subscribe, keep watching, keep learning, and we'll see you in the next video.